This lesson is an intro to stoichiometry, and you should have learned from this point that stoichiometry deals with calculations in the quantities of reactants and products in a chemical reaction. We're going to start by looking at an example that deals with the Haber process, which is the production of NH3 formed by reacting N2 and H2 gas. You can follow in your workbook, and we will use the steps outlined to try to solve this problem. So for any stoichiometry problem, it's always based on a chemical reaction, so you write the balanced chemical reaction. And to balance it, we need to have a 3 in front of the H2 and a 2 in front of the NH3. And this tells us that for every 1 molecule of N2 gas, we need 3 molecules of H2 gas to react with 2 molecules of NH3 gas. And since the number of molecules is related directly to the number of moles, using Avogadro's number, it's the same thing as saying that you have 1 mole of N2 gas reacting with 3 moles of H2 gas to form 2 moles of NH3 gas. And we also know that moles are related to mass using molar mass, so by using the molar ratios within this chemical reaction, we can figure out amounts of things that are going on. Okay? So now when we take a look at step 2, we will notice that it says to write the given and required quantities underneath the appropriate compound in the chemical equation. So when we take a look at the example, it's asking us how many moles of NH3 are produced when we have 2.8 moles of H2 gas. So I'm going to write down that I have 2.8 moles of H2 gas underneath H2 gas, and I want to find the number of moles of NH3. Now we use molar ratios to find the unknown quantity, or in this case, the number of moles of NH3. So let's start. We've got 2.8 moles of H2, and I want to find out how much NH3, so using the factor label method, what I want goes on top, and what I have, or I'm trying to get rid of, goes on the bottom. Now, according to the chemical equation, we see that we have 2 moles of NH3 for every 3 moles of H2 gas. So we have 2 moles of NH3 for every 3 moles of H2 gas. So we see that when we calculate, we get 1.9 moles of NH3, and we will see that the moles of H2 cancel out to leave us with moles of NH3. And we can use this notation to show that we've got the N for moles and subscript NH3 for NH3, so the moles of NH3 equals 1.9 moles. Now let's try an example where we're dealing with mass. So here we've got a reaction and it's balanced for us, so we're just going to rewrite the balanced chemical equation. And the problem tells us that we have 1.00 times 10 to the 3 grams of CO2, and we want to find out how many grams of LiOH is required. Okay, so our mass of CO2 is 1.00 times 10 to the 3 grams, and we want to find out the mass of LiOH. Okay. So notice that the first two steps are the same, balanced chemical equation, then we write down the given and required. Now what we have to do is, since they don't give us moles, we have to convert to moles. So step 3 is a new step. To do so, we take a look at what's given. We have mass of CO2, which is 1.00 times 10 to the 3 grams. And we know that moles is equal to mass divided by molar mass. So I need the molar mass of CO2, which is equal to 12.01 grams per mole for carbon, plus 2 times 16.00 grams per mole for oxygen, to give us a total of 44.01 grams per mole. So when I use that molar mass and the mass of CO2, I have 1.00 times 10 to the 3 grams divided by 44.01 grams per mole, and that gives me a value of 22.72 moles. And this is moles of CO2. Now, once we have our moles, then we can use our molar ratios to find the unknown quantity. So when I go back, I see that I have 1 mole of CO2 for every 2 moles of LiOH. So, since we know that we've got 22.72 moles of CO2, and I want to find out the moles of LiOH, my LiOH will go onto the top, which is 2 moles. My CO2 goes on the bottom, which is 1 mole. So my moles of CO2 cancel, and in the end I get 45.44 moles. Okay? And this is moles of LiOH. Now the question asked us to find the mass of LiOH. So now I convert to mass using the same formula, but I rearrange. So now mass will equal moles times molar mass, and we're looking for mass of LiOH. So moles is 45.44 moles. If we calculate the molar mass of LiOH, we get 23.95 grams per mole. And our final answer will be 10.88 grams. And since we started with 3 significant digits, we're going to round our final answer to 3 significant digits. So whenever you're trying a simple stoichiometry problem, you will either use the 3 steps we saw in example 1 or the 5 steps that we see here in example 2. So try a few of the questions in your workbook, check your answers both online and in the classroom, and then return to the next video on limiting reactant.